for you to look at. When you try to evaluate the limit at 4, you notice that there's a problem. You end up dividing by 0, so you have to be able to factor the numerator and the denominator.
So that just becomes -4 plus 4. Eight.
Yeah, so getting you end up getting, you do want to show like 0 over 0 when you evaluate, and then you can either factor off to the side or you can factor within the limit. It doesn't really matter, but you want to show your net result as the limit as x approaches 4 of x plus 4, and then you put 4 in and you get 8.
Okay.
All right, let's try. This is just a same style of question, but it's the same process. You've got issues. So give this one a try, please.
All right. What does the top become?
Yeah, so the top, you always try the greatest common factor as the first factoring method, and
yeah,
this time it's just a letter. It's just x and x minus 4.
That's why. Okay. So then it's just 4 over 4 plus 1. So 4/5.
Yes. Yep. Because those cancel, and just full very formal here, you would show x over x plus 1, and then that's when you finally evaluate. Now, like a really similar problem to this that has the appearance of being one that works. If I change this to a +3 down here on the bottom, okay, if you aren't careful and you just think, oh, it's going to be one of those that cancels, this one actually works out just fine. It ends up being 4 squared minus 4 times 4, which is 0. That's okay. 4 squared plus 3 times 4 minus 4. It ends up being 0 on top, and then 24 on the bottom. So it's just being 0.
Okay.
So you want to just be very careful that like the factoring actually cancels, and you're not just
right.
Thinking, oh, it must cancel, because that's what we've always seen. And I mean, that's really it. I mean, without getting into some of the weird exceptions, you've got, I mean, that's it. You're going to see one where everything cancels.
Okay.
So if that's good enough, we can move on to derivative rules.
Yeah, is it still 2.2, or is that 2.3?
Well, I went to 2.3, and it's just continuity. I mean, it's nothing that you showed me before. Now we can work through these examples if you think they will be on there.
Oh, maybe he didn't have anything on the sample test about one-sided limits. I don't think.
No. Nothing on there. I mean, I had to go to 2.5 to find questions like your practice exam.
The ones that are like on the bottom of 2.2, page like 4, those ones you just plug in. You would just plug in the number like directly, like.
Yeah, like the limit as x approaches 5.
Yeah.
Even the one all the way on the bottom. That's a rational. Yeah, I mean, you always try putting the number in first.
Okay. Yeah, I mean, I don't think if it wasn't on the sample exam, I don't think he's gonna put it like continuity or something on there. So yeah, we can go to the next.
So what I recall is the next topic was just, derivatives, like something like y equals 4x to the 9th minus 20x squared plus 3 over x. Something like this would be.
Oh, sorry. He does say topic 5 is limits and continuity. So maybe we should go over some of the continuity stuff.
Okay. Yeah, we can do that here. Let me get that one open. Okay, so we'll start with this example that asks if the function is continuous at x equals 1. So there's a couple of things that you're looking for. The first is would be like a hole, and the second is a vertical asymptote. So you could but like in terms of like what you do, you just start by plugging 1 in.
Okay, so
for x
squared plus 2 minus 3.
It's 1 times 1. It's 1 is the middle term there.
Oh yeah.
1 minus 1 on the bottom. So it ends up being minus 1 over 0. And this is bad. I mean, anytime you divide by 0, it's a problem. So this is not continuous. Now it doesn't go on. I guess the notes do go on to sort of ask, like, what is it? What's going on there? But it has to be defined at that point for it to be continuous. So
Okay.
That's kind of a starting point. So, the more, I guess the better question here is this one where it asks where the function is continuous. Basically, it's asking for the domain of the function. Okay, so really continuity is a lot like domain. Not completely, but for us, it's good enough. So you would want to factor the numerator and the denominator. So the bottom, I think, is we just did. It's x minus 4x plus 1. The numerator is a little harder. You've got this x to the 4th minus 3x squared plus 2. If you could visualize it really being like a u squared minus 3u plus 2, like that, it does factor nicely. So you're still trying to find two numbers that multiply to 2 but add up to -3. X squared minus 2, x squared minus 1. That's all in the numerator. And so you can further expand, like this one is still difference of squares.
So x minus 1, x plus 1.
So your numerator is x. And then this one isn't, it is, but it isn't difference of squares. So you don't have to deal with it. The reason you have to do the one on the right is because it does cancel with something on the bottom. Like this. But in terms of domain, you only need to focus on the denominator.
Okay.
You only care about where the denominator equals 0. So you can see that it equals 0 when x is 4 and when x is -1. So you put those on a number line, and those are the excluded values at -1 and +4. So those are excluded, and then everything else is okay. So your domain minus infinity,
Negative.
yeah, -1,
Okay.
then in between there. And these are all the places where the graph is continuous.
Okay. I remember this. Yeah.
So it's a little bit deceptive because you spend a lot of time in the numerator, but you actually only care about the denominator.
Right. Okay. But you need to factor out the numerator for the.
You actually don't have to in this problem, but it's like it leads to some other things. Like if it asked what type of discontinuity is at each point, then you would need to know.
Oh, because the x plus ones cancel, which means that there's pole, right?
There's a hole, yeah, there's a hole, and
Okay.
then the 4 is the vertical asymptote.
Okay. All right.
This next example, I guess, is sort of interesting. So it says, where is h of x, which equals cosine x squared minus 5x plus 2 continuous? So this is relying on you to remember, like, what does a cosine graph look like? And we were talking about that in our first lesson about how you've got sine and cosine. It comes down, goes back up, but it goes on forever in both directions. There's no issues there. So the question is like, are there any bad inputs? Like, in other words, is there any place where x squared minus 5x plus 2 is bad? And that's, it's kind of general, but because cosine is defined everywhere, there are no bad inputs for it.
Okay.
Okay, so it's the cosine is fine, the x squared minus 5x plus 2 is fine. So since they're both fine, there's no issues. Okay, but let me give you one where there would be a problem, because I think that's a reasonable question to ask. Okay, so now same deal. Cosine's fine everywhere, but 1 over x is not. The problem with 1 over x is that x cannot be 0.
Okay.
So since x cannot be 0, that also affects cosine. Cosine is undefined at 0 as a result of that. So go ahead.
What do you mean on the top one when x squared minus 5x plus 2 is bad? Because if there's no bad inputs.
It's a question. It's like, is it bad anywhere? Is it like, okay. And it's a nice U-shaped graph. There's no places where it's undefined.
Okay.
So you're looking for and the analogy, I don't know how this works for you, but like, think of like the 1 over x is like someone who's got a food allergy in your family, and then cosine is the family. So like, if you make dinner, you have to exclude something for everyone in the family, even though it's just for the one person. So you look for that, like wherever it's excluded there, and then you move on from that.
Okay.
Okay, now you were asking me a few minutes ago, the most basic type of limit that you will calculate is you just put the number in to the function.
So okay.
So you don't know how, you don't have to know what this is. You just have to know that it is a number. It's an output. There's no issues there. So you're generally looking for like division by 0 or square roots of negatives, things like that. Okay, now moving on to, I do think this is actually the question we get on an exam, this one upcoming here. This is the, is it continuous for a piecewise function? And I'm almost positive you and I have some old lessons that cover just a couple more of these.
Piecewise.
Yes. So you look at them individually. You're like 2x plus 1. 2x plus 1 is the graph of a line, and lines are good. Like, there's no issues with lines. Lines are great. Okay. And then 1/3 x plus 2. Similarly, that's great as well. Okay. So there's no individual problems, but because they're piecewise, they're broken apart at this value of 1. So you have to check and this is what you're kind of alluding to earlier, you have to check that the limit as x approaches 1 from the left, f of x, equals the limit as x approaches 1 from the right, f of x. Okay, now in terms of like what you do, you're going to put 1 in each of those, and you're going to see if you get the same output.
Okay.
So this one is 2 times 1 plus 1. This one is 1/3 times 1 plus 2.
So no.
So this is the first and the second, but then there's a third criteria. The third criteria is you have to actually evaluate at 1, and they have to all be the same.
Wait, say that again. Sorry.
All right, so the limit from the left has to be the same as the limit of the right. That's the first two pieces of it. I know these aren't equal, but let's just say they were for a moment. The third thing is you have to actually evaluate the function at that point, which is almost always one of the values you already had.
Okay.
So let me give you one that is continuous, so you can see that if you're ready for it.
Yeah.
Okay, so let's say it's f of x equals x squared for x less than -1, and then let's say x for x greater than -1. Sorry, negative x for x greater than -1, or greater than or equal to. Okay, let's do that. So you have to find the limit as x approaches -1 from the left, f of x, the limit as x approaches -1 from the right, f of x, and then f of -1. These
So
have
the
to,
one.
go ahead.
So for the one for the left, you use the x squared, right?
Yes.
So that's less than the negative x. So that's 1, and then they're both 1.
Yeah. But it's almost always the case that you're reusing one of the limits to find this functional output.
So for the one that we just did above,
Yes.
for the f of 1, you just write does not exist, or
No, it's 1 plus 2. It's this third one, or it's the second. I'm sorry, it's the second piece of the piecewise. Because how it's equal to
because
1.
it's defined for
Yeah.
Okay. So when is it like if they don't match up, it does not exist? Isn't that like one of the cases?
That's what we got here. See how it's 3 7/3.
Yeah.
So they're different. So this is not continuous.
Oh, it's not.
They have to be the same.
Okay.
Whereas the one we just did, they're all the same. So we're happy. We're like, okay, they're all the same. Yeah.
Continuous.
Continuous.
Okay, cool.
Okay. We can move on to the next 2.4, I guess.
Yeah, that's the like long way of doing the derivative, I think, right?
Yes, we should just maybe do one. Oh, here's a good one. I'll just assume this is it. So let's go with the limit. I'm sorry. We want to use, and that it has to say this language, use the definition of the derivative to find f prime of x for f of x equals x plus 1 squared. So there's a couple ways to do this problem. I'll write out the limit definition. And you do have to know that. You have to, have that tucked away so you can pull it out on the exam. So there's two options. The first option is to go x plus h plus 1 squared, like that, because you have to put x plus h in for x, and then you essentially expand it like this.
Oh,
Okay. Or number two is to first FOIL x plus 1 squared. So x plus 1 times x plus 1. And then put in x plus h for x. They both give you the same result, but
Okay.
this is one you ought to try here on your own. See what you come up with.
All right.
Okay.
I feel like something is not working.
Which one did you try?
The
number,
second one.
okay.
Yeah.
So the second one, you have to FOIL x plus h times x plus h.
I did that.
Let's just make sure we're consistent here. So it's 2xh plus h squared. Is that what you got? Okay. So you got all this that I'm about to copy, and then that's not good. Let's do it right there. Let's try this again. Wow. Okay. Come down a little bit so I can get this to paste. All right. So you take in the limit as h goes to 0, and then you're subtracting the original function, which is x plus 1 squared.
Should you FOIL that out?
Yes.
Okay,
yes.
I did that.
So it ends up being minus x squared minus 2x minus 1. So let me just move all this down a little bit. So then you should send all over h, and then you should have a bunch of cancellations. Hopefully we got it the same here. So the x squareds cancel, the 2x cancels, and the 1s cancel. So everything left over has an h in it. 2xh, h squared, 2h. Sorry about that. So then you divide, you get the limit as h goes to 0, 2xh plus h squared plus 2h over h. And then this is when you can actually divide. So it's 2x plus h plus 2. And then you put 0 in for h, not x. Something like that.
How did you get, can you scroll up a little?
Yes.
Oh, because it's negative x squared. Okay, that's where I messed up because I was like, there's not a cancellation there. Okay.
Yeah, it always cancels with these.
That's why I was confused. I was like, something's not working.
So this you got to be careful here because like I like this problem because you it's not any harder than the ones you've been doing, but it does require you to FOIL and some other stuff. It didn't appear to me that you would get one like this. It appeared to me you would get one more straightforward that's already factored, kind of like an x squared plus 2x plus 1. And
Huh.
you know, I just caution you that you probably do understand how to do this. It's just that this is a different problem altogether.
Yeah.
Okay. Do we want to do one more difference quotient? I'm sorry, definition of derivative.
Yeah.
Okay, let's make this a little bit better. Let's go f of x equals x squared minus 2x. And let's have you try this one, please.
I got h minus 2, but shouldn't there not be an h anymore?
Yeah, there cannot be an h because it's 0. You're doing this. So let's just
Oh
check.
wait, that's why. So it should be. I plugged it in for the 2, so it should just be 2x minus 2.
Yes.
That's what I got.
Good. So here's the thing, you know how to take the derivative of this already. So you should write that down on
Oh
your
yeah.
paper
Okay. Smart.
and
Yeah.
then make sure your answer matches
Matches
what you
that.
know to
Right.
be true. And then if it doesn't, I mean, that doesn't always work because then you're trying to always get it to make it look like the answer, but that is the steps here that I would take.
Okay.
Okay, so we're moving on to some derivative rules. Your instructor has written a bunch of them down. We talked about them yesterday. So let me just go through some of the examples that he gives. Let's say it's 12x to the 100 power. This is a power rule derivative.
It's 100 times 12, 1200 x to the 99.
Yes. Then the next type of example I see is we'll go 2
Wouldn't
over.
it be y? Wouldn't it be y prime equals?
Yeah. Yes. Yes. Y prime or dy dx, or and actually let me do some function notation because I see that your instructor uses that here as well. So b of x equals 2 over x to the 50. And yeah, it's also this as well, this power rule. You just have to change the exponent first.
Okay. Um, So you just bring the x to the 50 up to the numerator, basically.
Yeah, I would write it like this before
Okay.
before you take a derivative.
So then negative 100 x to the minus 1, negative 51.
Yes.
Okay.
All right, and then your instructor gave you a problem like this. Let's go, I don't know, f of r equals r to the pi. And you're supposed to find f prime of r.
Okay, so pi r to the pi minus 1.
Yes. If it were pi squared, it would be pi squared minus 1, pi squared. They're just numbers. They're just it's like that. The next one are getting into roots. So let's say I ask you for the 7th root of x to the 5th, and this is p of x equals this, and I want p prime of x. You want to first rewrite this as a,
Yeah, so it's x to the 5, like 5 over 7.
Yep.
And then, so it's 5 7 x, and then let's do 5 7 minus 1. So then 5 7 minus 7 to the negative 2 sevenths.
yeah, good. And then another variation of this would be like d of L equals 5 over the cube root of L squared. And you have to find the derivative of this.
L to the 2/3. 5 L to the negative 2/3, and then it's fine. Negative 10/3 L to the negative 5/3 is what I got.
Yes, that's correct.
Okay.
Okay, so then your instructor moved to kind of a synthesis of them. And that's kind of the problems we saw in the practice exam. And he also, oddly enough, switched to this notation here, which
he is an odd guy.
yeah, it's like, one day I love functions, now I like this notation. So give this a try, please.
All right. Oh, so this is not using like the limit definitions. It's
No,
just
this
okay.
is yeah. You only get one of those where it says, use it, and then
6t minus 6t plus 5.
6t plus 5, yeah. Okay, so let's try another one. Let's go dp of 3 over p cubed minus 1 over square root of p.
Negative 9p to the negative 4th plus 1/2 p to the negative 3/2.
I missed some of that. So let me give you, it's negative 9 p to the minus 4
Yeah, got that.
And then it's going to be plus 1/2 p to the minus 3/2.
Yeah, that's what I got.
Okay. That's about as difficult as you can expect.
Okay.
Grab your, I should have pulled up your practice exam. Let me do that again to make sure we're consistent with that. Yeah. Okay. So now we're moving on to like some product rule, I guess, questions.
Yeah, I think product and quotient is the last thing, right?
Yeah. Let's go d dy of y squared plus 1, y minus 3.
Okay.
And simplify as much as possible.
Right. Derivative of y minus 3, would that just be y squared? I mean, not y squared, y prime.
It's just one. Just one.
Oh, because it's like x.
Yeah, I'm picking a different variables, but yes, it's
Okay. I got 3y squared minus 6y plus 1.
okay. Let me finish up here. Y squared plus 1 plus 2y squared minus 6y. Yeah, that looks good.
Cool.
So another use of the product rule was something like this: x squared times g of x, and it would be like d dx. What we want it at x equals 2, and g of 2 is 1, and g prime of 2 is 1/2. So this is another product rule problem, but you're evaluating it at a point.
Okay.
So give that a try, please, and see what you come up with.
I got 6.
Okay, I'm almost caught up to you here. G prime of 2 plus 2 times 2, g of 2. So that's your 4 times 1/2 plus 4 times 1. Yeah, it looks like it's 6. Good. Okay, so we'll do a couple of quotient rule problems here. Let's go. Let me just check your practice exam again, see if I get one in line with that. All right, let's go. Q of R equals R squared minus 1 over R. Let me change this, R plus 3. And we want Q prime of -1 this time.
Okay.
How are you doing on this one?
Almost done.
Okay.
Okay, yeah, I got -1.
Great.
I like simplified too much and then I did the -1, which is why it like took me longer. I should have put it in earlier.
Yes, good to realize that. And the r² - 1 goes away. I mean, that's another little shortcut on this one. But
Right.
good, that's really good. So let's look at one more of these sort of symbolic derivatives. Let's say r of p equals, I'm sorry, p over h of p, and we want to find r prime of, give me just a moment here. Let's find r prime of 1. And I'll tell you that h of 1 is 2 and h prime of 1 is -2.
Okay.
This is a quotient rule problem.
All right. I got 1. Yeah.
Awesome. Anything else you want us to cover today? We pretty much covered everything.
Let me look sample exam one more time. Oh, do you still have, like, I sent it for like one of the, I think the lesson that we did earlier last week, where it was like a image one, and it was
Yeah.
like the log ones.
Yes.
Maybe we could do one or two of the log or e problems. Just
Okay. Yeah, they're really hard to make up. The log ones that work nicely, but
we could do the one that I sent to, I don't know if you have it on hand. So
yeah, I got it right here. So this one's not too bad to make up because it actually does work out nicely. So let me change it up slightly. Log base 3 x plus 4 minus log base 3 of x equals 6. Okay. So the main thing here is that the difference becomes a quotient.
Okay. So
And actually, I made this number too large on the right. Sorry, let me make it a more reasonable number. Man, I'm way off today. Okay. Yeah, she's not going to do 6 to the 5th. That's a large number. All right, so you undo it with 3, base of 3 on both sides. That was an important step here. And so you get x plus 4 over x equals 9. And that's really a fraction. So you cross multiply here. You get x plus 4 equals 9x. Subtract x and divide by 8. And it ends up working out nicely on that.
okay, awesome.
So you just remember the difference becomes a quotient, a product becomes a sum. We did a product one that I would practice again because it had 2 solutions, one that did not work out. And
Yeah.
then
Okay.
we'll do one real quick with E. Let's say 4 equals 2e to the x minus 1. Okay, so to solve this, you
Do the ln
you do
or
that after.
divide
Yeah,
by 2. Yeah.
if there's something added or multiplying, you get rid of that first. Then you use natural logarithm of both sides.
It's going to get ln 2
Yeah.
equals x minus 1, x equals ln 2 plus 1.
Yeah.
Okay.
And there's no really not a good way to check these. So you just have to be comfortable with your steps. You wouldn't try putting it back into the original. I mean, it does work, but it's just not, it's not something you want to do.
Okay. Awesome.
Okay. Thank you so much. I hope I can help
Thank
you the
you.
rest of the semester. I'll send you notes here shortly. I'll see you next time.
All right. Thank you. Bye.
Okay, bye now.